name is Ghaziabad. I am from ABES Engineering College, IT department. So today we will be discussing bus arbitration from the computer organization architecture. So first of all, the little outline of the topic. First, we will study about what is bus arbitration, how the arbitration will happen in the computer organization. Second is how many approaches are there for the arbitration and the advantages and disadvantages related to the each approach. And last one is the comparison of all the methods for the bus arbitrations. First of all, the agenda is what is arbitration. In a loosely coupled system, all the processors basically use their local buses for their personal use. But if they want to use the system bus, so they have to send the request, they will get the access. After that, they can use the system bus. So when more than one user want to send or want to use the system bus, so they have to send the request. So there will be a contest to get the access of the system bus. This contest is called the bus arbitration. So there will be a master who will resolve this type of contest or this type of congestion. So that will be like bus arbiter. So basically we have three main methods to resolve this type of contest or this type of problem. First one is daisy chaining method. Second one is polling method. Third one is independent method. Now we will study about each and every method one by one. So first method is daisy chaining method. In this method, there are three lines, one for the request sending, second for the access grant, third for the busy line. There are more than one modules. Module is like a bus master. These modules want to use the system. So first of all, they have to send the request to the bus arbiter. Then bus arbiter will decide who will get the access. For example, take an example. Module number 1 want to access the bus. So he will send the request with the help of this orange line. This is the request line. Bus arbiter will get the request from the module 1 and he will send the grant of the bus through this blue line. This is the grant line. But there is a problem. So grant will be assigned sequentially. It means like first of all, the nearest one will get the access, then the second nearest, then the third nearest. If module 1 want the access of the system, so before the module 1 will get the access, module 0 will get the access. So the access will propagate from starting point to the 0th module. If 0th module use the access, then he can use. Otherwise, he will pass the access to the module 1. Only then module 1 will get the system bus. When the module 1 will get the system bus, he will make this busy line 1. 1 means the system bus is used by someone and this is busy. Nobody can use or nobody can access the already occupied system bus. When this module 1 will complete the task, he will make this busy line 0. It means now system will be available to the everybody. Here are some challenges with this technique. Basically, this technique is a little simpler. So there are some advantages. The design is simple and the number of control line are very less. One for the request, second for the busy line and third for the access grant. Third one is also adding the new bus master is easy. For example, like if you want to add the n plus 1 number module, so we can easily add the next bus master in the last of the location. There are some disadvantages with the daisy chaining. This is the basic technique. So first disadvantage is bus is granted serially, as I have mentioned earlier. So first of all, the first or nearest master will get the access, then the second nearest, then the third nearest. So there will be like propagation. Take a scenario. For example, nth, or it means like we have 5 modules. This is the 5th module. If 5th module want to get the system bus, so he will have to wait from First module 0 will get the access, then module 1, then module 2, then module 3, then module 5. So module 5 will get the access in the very last. So this is one of the disadvantage of this technique. Second technique is failure of one of the device may fail the entire system. So the reliability of the system is very, very poor. Take a example. For example, this module number 0 is like failed or dead. So as per the rule, the module 0 will get the access in the first position, but he cannot pass the grant to the next one. So if this module will get dead, then the entire system will be failed. So reliability of this method is extremely poor. So we have the next method. This is the polling method. So it will resolve the solution, or it will resolve the problem of the daisy chaining. So in the daisy chaining, we basically get the access in the serially, but we have to wait for the grant. But in this technique, we have some sort of different method. So in the polling method, the access grant method is little different. So for example, we have 8 modules. With these modules are numbered like 0, 1, then 8. So if we have 8 modules, so we can choose the module, or we can send the grant signal to these modules by one, or sorry, not one by one. We can directly send the grant signal to the each and everybody if we want. So for example, if we have 8 module or 8 bus masters, so we can make the arrangement of the bus something like that. So 8, so we need 3 bits to send the signal to these masters. So 3 bit, we have to make the combination of the 3 bit 0, 0, 0, 0, 0, 1, 0, 1, 0. Similarly, last one will be 111. So we have 3 grant line, one for the request, second for the busy line, and the third for the grant line. In this grant line, we need 3 parallel lines, and each line of the grant will be connected to all the bus masters. For example, the module 1 sending the request to get the access. So he will send the access with this orange line, and bus arbiter will send the grant. So he will send 0, 0, 1. So it means if we send 0, 0, 0, the 0th master will get the access. If we send 0, 0, 1, the first master will get the access. If we send 0, 1, 0, then the second master will get the access. So the problem of the sequentially signal granting or grant signal will be resolved with the help of this method. But here is a problem. The problem is the complexity of the wire and the cost of the wire. So there are some advantages and the disadvantage of this method. So we will see. Yes, as per the rule, the method is quite simple as the daisy chaining. The priority is little flexible comparative to the daisy chaining, and can easily be changed by the altering the polling sequence. For example, if we want to assign the system access to the third module, so we can easily send like 0, 1. If the one module will fail, the entire system does not fail. This was the prime disadvantage of the daisy chaining, but this was resolved in this method. There are some disadvantages with this method. Adding more bus master is difficult as it increases the number of address line of the circuit. Take an example. For example, so we have total 8 bus master in the mentioned scenario. For example, if we want to add 1 bus master, so total will be 9. So to address these 9 bus master, we have to add 1 more access line here. So there will be more connections, there will be more wires, and there will be more complexity. So there is only one disadvantage with this method. The problem is if you extend the wire, or actually you extend the network, so you have to add the bus masters, extra bus masters. So you have to increase the number of buses or number of connections in the network. Method is independent request method. This is like everybody have their own resources. So there are some modules they want to access the signal or they want to access the system bus. So they have their separate request line and separate grant line. Module 1 will have their separate request line and separate grant line. As per the instruction, all the bus master will have their separate request line and separate grant line. Here, the role of the bus arbiter will get increased. So he will assign the system or system bus with the priority of the module. So here the priority mechanism is little better than the previous one technique. Whenever a system will get the access, he will make this busy line 1. It means the system is getting used by the bus master. So if anybody want to use, so they have to send the request and wait in the queue. So there are some advantages of the independent request system. Bus arbitration is little fast and dynamic. Priority is also possible in this technique. The speed of the bus arbitration is independent of the number of devices. So the number of devices or the number of bus master doesn't affect the performance of this method. So there are disadvantages of this method. Number of control line required is more. For example, we have 3 bus masters. They want to use the system bus. So we have 3 into 2. Total number of wire required is 6 plus 1 for the busy line, and the hardware cost is also high. This is the basic like connected to the each and everything. Like if we increase the bus master, so we have to increase the number of wires. Or if we increase the number of wires, then cost will get automatically increase. Next is the basic comparison of each and every methods. There are some parameters. On the basis of these parameters, we compare the bus arbitration. First of all is the performance. Designing performance wise is like little poor. So the reason behind this poor performance is the reliability issue. But in case of polling, the better performance than the daisy chaining. In case of independent, this will be like better than the polling. If we talk about the reliability, the daisy chaining is the worst one. Then polling is better than daisy chaining, and independent is also good in case of reliability. If we talk about the priority, in case of daisy chaining, the first one or nearest one will get the access first, then the next, then next, then next. So the priority mechanism is also poor in the daisy chaining, and in case of polling and independent request, mechanism is little better. So if we want to add the system, if we extend the network, so in case of daisy chaining, the addition is easy. In case of polling, we have to increase the number of wires, so extension is little costly. In case of independent, it will be much costly. So if the total number of lines required to build a network having 1024 compute. So in case of daisy chaining, 1 for the request, 1 for the grant, and 1 for the busy line. So the total number of lines required in case of daisy chaining depends on the number of computers connected in the net. In case of polling, it is directly depends on the number of system connected in the network. For example, we have 1024 total system connected in the network. So the number of address line is required 2 to the power 10 for the grant line, 1 for the total number of line required 10 for the grant, 1 for the request, and 1 for the busy purpose. In case of independence, so we need 2 into 1024 is equals to 2048 request plus grant and 1 for the busy line. So if we talk about the application of these methods, so first daisy chaining is used in the smallest network. So polling method used in the large, greater than the, as per the like much greater than the daisy chaining method, and the independent request used in those organizations where cost is not the issue. Greater performance is the key requirement. For example, bank is the basic example of this type of scenario. So where in bank